All right, example two, more identities. So it says illustrate identity two from the last page by filling in the table to the right. What do you notice? All right, and so I'm gonna do the second column for us, and then I'm gonna have you guys do the third column as an exercise on your own. All right, and so we can see that in the first column, we have our data values. We have 0, pi over 6, pi over 4, pi over 3, pi over 2. Second column, we have cosine of theta. The third column, we have sine of theta plus pi over 2. All right. And so in the second column, we're going to be filling in the value of cosine for all these different data values, right? So the first data value that we have is cosine or is 0. Right? So what we're gonna write in this box is the value of the cosine of 0, right? So using my memory of the unit circle, I know that this is equal to 1. Cosine of 0 is equal to 1, right? Next data value is pi over 6. The cosine of pi over 6 is the square root of 3 divided by 2. Cosine of pi over 4 is the square root of 2 divided by 2. Cosine of pi over 3 is 1/2, and cosine of pi over 2 is 0. All right, so take a moment, pause the video, and fill in the values for sine of theta plus pi over 2. All right, cool. So let's start filling these in. All right, so for this expression, right, we're gonna be adding pi over 2 to all these different data values, right? So for this one, we're gonna have the sine of 0 plus pi over 2, which is just pi over 2. So we're taking the sine of pi over 2, and the sine of pi over 2 is in fact 1. For the second one, we're going to be adding pi over 2 to pi over 6. So when we do that, right, we're going to be left with the sine of 2 pi over 3, 2 pi over 3, which is going to be equal to the square root of 3 over 2. And I got this from my memory of the unit circle. Cool. Next one, we're going to be adding pi over 4 to pi over 2. So when we do that, we're going to get the sine of 3 pi over 4. Yeah, the sine of 3 pi over 4. And the sine of 3 pi over 4 is equal to the square root of 2 over 2. Right, next one is pi over 3. So I'm going to be adding pi over 3 to pi over 2. So pi over 3 plus pi over 2 gives me 5 pi over 6. Right, so the sine of 5 pi over 6 is 1/2. Then I'm going to have sine of pi over 2 plus sine of, or plus pi over 2. Pi over 2 plus pi over 2 is just pi. And the sine of pi is in fact 0. All right, cool, cool, cool. So we were able to verify that. Okay, where did my paper go? Sorry, guys. Oops. Never mind, never mind. Okay, we're all good. Okay, cool. Yeah, so cool. We finished filling in our table. And so what do we notice? Right? What do we notice? So clearly, right, we can see that for all values of data in this table, right, for all values of data, the output values of cosine of theta and sine of theta plus pi over 2 are the same, right? And in fact, for all values of theta, right, not just the ones that we have in this table, this is going to be true, right? And then this should make sense, right? Right. So because our analysis from example 1 demonstrated, right, that cosine of theta and sine of theta plus pi over 2 are in fact identical equations, right? And so we can write this makes sense since cosine of theta is equal to the sine of theta plus pi over 2. In example 1, we saw that these are identical functions, and so this should have not been a surprise to us, right? We have verified. We have illustrated identity number 2, the fact that cosine of theta is equal to sine of theta plus pi over 2. All right, let's keep going. And so more identities. All right, and so so far we've been relating the sine and the cosine, right, to this angle right at the bottom of our triangle right here, to this angle theta, right? But there's nothing, right, that says that we can't use the angle on top here to define sine and cosine. Okay, cool. And so that's exactly what we're gonna be doing. We're gonna be seeing what happens when we use the angle on top as opposed to using the bottom angle of this triangle to get our trigonometric ratios. Okay, so some observations about this is right. This is y, this is x, right? And so we know, right, that x is equal to cosine of theta, and we also know that y is equal to sine of theta, right? For any triangle on the unit circle that we draw, these relationships are always going to show up, right? X is going to be equal to cosine of theta, y is going to be equal to sine of theta, right? And that's when we're using this as our reference angle. But what happens when we use the third angle inside our triangle, right? Not the right triangle, not this bottom angle, but the one that's all the way on top over here. Right, and so remember, the angles in a triangle add up to 180 degrees. And since this is a right triangle, we know for a fact that this angle right here measures 90 degrees. This angle measures theta, right? And so we know that all these three angles must add up to 90 degrees. And so since one of our angles is already 90 degrees, that must means that the other two angles must also add up to 90 degrees, right? For a total of 180 degrees. So even though we don't know the measurement of this bottom angle right here, we can still define the third angle using the second angle, right? By saying that this angle must measure pi over 2 minus the measurement of this angle right here, right? So that's the measurement of this top angle over here, pi over 2 radians minus the measurement of this bottom angle over here, theta. All right, and so if I'm using this top angle, right, to generate the relationship between sine and cosine, right, I'm gonna have, okay, the cosine of pi over 2 minus theta, right, using SOHCAHTOA, it's still adjacent over hypotenuse, right? So the adjacent side is now this vertical leg, y, right? So this is going to be equal to y divided by the value of the hypotenuse. And the value of our hypotenuse is just 1, right? So anytime I divide by 1, it's just, we don't change the value of it. It's just that exact same, it's the exact same thing that we have in the numerator. So this is going to be equal to y. Oh, man. No, it's bugging. Hold on. Okay, there we go. So that's going to be equal to y, right? But look, don't I already have another expression that has y equal to something? It says that y is equal to sine of theta, right? So this is actually also equal to sine of theta, right? So I get this new identity, the fact that the cosine of pi over 2 minus theta is equal to sine of theta. And then if I do the exact same thing for sine, right, but now I'm going to take the sine of that top angle, so the sine of pi over 2 minus theta, right, that's going to be equal to opposite over hypotenuse, so the leg that is opposite from this top angle right here is x, and then that's divided by the hypotenuse, which has a value of 1, which is just going to be equal to x. But look, I already have an expression that's relating x to something else. X is equal to cosine of theta. So that must mean that this is also equal to cosine of theta. So when I rewrite this, I'm going to get that sine of pi over 2 minus theta is also equal to cosine of theta. So I get two new identities. All right, and those are these right here. We have our Pythagorean identity, right? And then we have this new identity here that says cosine of pi over 2 minus theta is equal to sine of theta. And then also sine of pi over 2 minus theta is equal to cosine of theta.